Okay, so second chapter of stats in year 13 is conditional probability. Um, this is a continuation really of what you did in year one. So there was a lot of work with Venn diagrams, the notation, um, and then uh, there's also talking about something called conditional probability. Okay, and that will be reflected by some more rules that we have here on the formula booklet. So set notation is things like this intersection sign, the intersection sign, the union sign, and the complement. You probably have seen these two before, maybe even all three of them. That's what we start with. Then we look at what conditional probability is in the sense of diagrams. So sometimes you can answer these questions just using a Venn diagram. So you don't need a formula or anything. For three, we look at using it without diagrams, and then we revisit tree diagrams. So a lot of this might be familiar. So a sample space shows all of the possible outcomes, and we're using this. We're using this to represent. What are we doing here? It looks like the outcomes from rolling a dice. So everything inside the E circle means it belongs in that group. Okay, you are in that group if you are inside the circle, anywhere inside the circle. So 2, 4, and 6 are inside the E circle because they are even numbers. The P circle, anything inside the P circle means that it is a prime number. Okay. Then there are some outcomes that belong to neither of these, so they sit outside. It's outside of both circles because it's outside of both sets. If something is inside one circle and inside the other, that means it belongs to both sets. Okay, so a quick recap of Venn diagrams there. Notation then. So we have the complement, the union, and the intersection. So what do they each mean? Well, complement is the one that's probably newest to you. If this means the probability of A or the outcome A, then A with this little dash means not A. So the way that you do this is you look at A and then you do everything that's not inside A. So that would be 3 and 1 and 5, for example. So everything that's not in A. A was even, so not even. A union B. A union B, when it's union, it means include more things. So anything in A, but also anything in B. This is quite a sort of a big region, is the best way to describe it. It's like this figure of eight shape. So anything in A, anything in B, they can be in both, they can be in one of them. It doesn't matter, but it's in at least one of them. Okay, this is called the union. So everything apart from the one. And intersection, this is tends to be a smaller subset, if you like. Okay, in set A and in set B at the same time. It's called the intersection, and there's only one number there, which is 2. So what have we got here? We've got some more difficult ones. So, for example, sorry, I shouldn't have revealed that before, but never mind. We've got here, it's in the set A and it's not in the set B. So, looking at the diagrams, it's in set A. So, you could start by looking at set A. And it's also, at the same time, it's not in B. So, you kind of need to discount anything from B. That leaves you with 4 and 6. Okay, that's sort of one of these shapes, something like that. Okay, let's try this one here. So start inwards and then work outwards. So we're looking for A union B. Well, if you remember from before, that's anything inside the two circles. And then this little dash on the outside means not. So this means not in the circles. Well, we know that that's 1 from before. You can put this in context. So each time here, A means even and B means prime, but it takes quite a long time to say that. That's why I'm saying A and B. And then here, start with the inside part of the brackets. So the part that's A and also B, the intersection, well, the intersection is this part here in the middle. And then this part here means not. So not the part in the middle. Well, which part is not the part in the middle? It's everything apart from the 2. So if we're talking about numbers, we're talking about rolling a number which is not even and prime, and that even and prime go together. So the wording is actually kind of difficult for how to express some of these situations. We can have more than one set being represented, or sorry, more than two. We've got three here. So A, B, and C. These are different sets, and if we're talking about inside those, then it belongs to them. So, for example, here, what can you say about this point? It's inside the A circle and the B and the C at the same time. So this is like the intersection of A and B and C, but it's bigger than that. It also seems to have, well, what can we say about this area here? This belongs to A and B. So this is like A intersection B. Well, what about this part? Well, that's A intersection B as well. So this part here is A intersection B, and also not C, whereas this part here is A and B and C. So if I wanted to make it look similar to the other one, it would be like that. So the C part doesn't seem to be important for what's shaded here. It seems to be about A and B. Okay, and in fact, that's what it is. Let's do another one. So all of A seems to be shaded, all of B. So as long as you're inside A and as long as you're inside B, well, that sounds like union. Remember, union is when you have lots of shading. What about this one? Well, we answered this one just a moment ago, didn't we? This is intersection of all three. It must be in all three. In A and also in B and also in C. All of these things at the same time. What about this one here? Well, it looks a lot like A, but something not happening with A. So it has to be A, but at the same time, what is it not allowed to be? It's not allowed to be C, it seems to be. Okay, we did this one. If you remember, we did that one before as well. Okay, what's this here? Well, apparently there's two ways that we could do this one. So I would probably start with trying to describe the white space. And what is the white space? Well, anything inside the circles is like that. And then this is the knot, isn't it? So I think that's the one that I would go for. Yeah, I would go for the right-hand side there. But you can also do this. So it has to not be in A and also not be in B and also not be in C all at the same time. I think you sort of get the idea for that one there. Okay. So Venn diagrams can contain the specific outcomes. So that's what we looked at, what you roll, basically the numbers that you roll. We just looked at that. The number of items in a set. So how many people are in that group? You saw this at GCSE. So this might be like 30 people study French, 16 people study German and French, and then 40 people only study German. That's what B is talking about. Okay. And C, you can actually use Venn diagrams with probabilities. You saw that in year one. So we've got some quick questions here. The card is selected at random out of 52. So that's probably something to do with the denominator. Let A be the event that the card is an ace, and D that it is a diamond. So just think about this for a second. Can you have an ace and a diamond at the same time? Yes. So there should be, there should be some overlap to your diagram. Can you have things that are outside both of them? So not an ace and also not a diamond? Yes, you can. So we'd expect to sort of see some numbers in these parts here. Okay. And you could divide the cards up as so. So 48 plus 4 gives you 52. So there's the one in the middle, the ace of diamonds. There's the three other aces. There's the 12 other diamonds. And then 36 of those cards sat on the outside. So can we find these probabilities? Yes. A and D, well, it's just one, isn't it? It's one out of those 52. A or D, anything inside the circle. So what's there? 16. You could simplify that. Just check if the question wants you to do that. Not A. The easiest way is to find A, which is 4, and then take that away. So 48. And then a bit more difficult here. So not A. So it's not A. So we're sort of looking at this part. So it could be the 12 or the 36, but it also has to be the same, has to be inside D. So it's that one there. It's that 12. Okay. couple more examples. So these are about using probabilities. Yeah, these are about using probabilities. So we've got A and B, and there was an A and B there. Okay, so you always start with the middlemost piece, so that's 0.25. A means everything inside A, so don't put 0.3 here, put 0.05 so that the whole A circle adds up to 0.3. And do the same for this one here, so 0.15. Okay, and then that means 0.55 outside. So explain why A and B are not independent. So did you remember, I think this one's on our formula booklet, did you remember the rules about independent events? Okay, so if they are independent events, the probability of A multiplied by the probability of B should be the same as the intersection. So in other words, 0.3 times 0.4 should be equal to 0.25 if it's independent. So this should not work. Okay. Draw a Venn diagram. Yeah. Well, oh, sorry, I didn't see that. We've also got probability of C. So they've added another one here. A and C are mutually exclusive. Remember, if something's mutually exclusive, it means that the circles do not overlap. There does not exist any intersection. You cannot simultaneously be in both groups. So, for example, what could you say? Maybe night and day are mutually exclusive. You can't have both at the same time. Don't talk about dawn or dusk or anything like that. Okay, they are separate circles. So do you notice on this diagram here that A and C, that they have no overlap between them? They might have overlap with B, and B might have overlap with C, but A and C themselves do not overlap. Okay. So this one here, you would have had to work backwards. Okay, so we looked at that part together. We looked at that. Yeah, a little bit of problem solving to work out the rest. Okay, so sorry, that was actually incomplete. I didn't see that one there. Find this probability. So start from the inside, work out. So A, but also not B. So A, but not B is that one there. Union C. So that means we have this number here, but we also have anything that's inside C. So that's 0.2. So 0.2 plus that 0.05, 0.25. Okay, so pause the video here and have a quick go at the question. This is a very, very common sort of exam question. So expect to see something maybe about independent, mutually exclusive, and some sort of problem solving where things are adding up to one. That's quite a common type of question. So let's take a look at this one here. So we should end up with an answer 0.15. Let's just have a very, very quick look. So that there's nothing really new in any of that text there. A and B are independent. That's quite important. So that means that the probability of A times the probability of B should be equal to the probability of A intersection B. And where does that take us? Well, look, that bit there is A intersection B. So that's 0.1. Probability of B, so anything inside the B set here. So that's 0.4. And can we use that to find the probability of A? That's essentially what we're doing. Okay. So we can find the probability of A by going backwards. And then once we've found this probability of A, take off the 0.1, and that will leave you with just the value of P. So that's what's going on over there. And that takes you up to exercise 2A.